Okay, this is the P1 paper from June 2023. It's question number 9, and as we can see by looking at it, this is trig functions, graphs of sine and cos, and then in a minute we're going to be doing some work on transforming trig functions. So if we look at part A, it says write down an expression for fx if fx is given by this graph here. What I'm going to point out on this original graph here then really is the fact that those two are 3 and minus 3, but we still have that the graph goes between 0 and 2 pi like that. So if I now compare that with my graph of cos x, which I've just drawn down here, graph of cos and sine for comparison purposes then, we can see that the only real difference between cos x and the graph that we've got are the fact that we've got plus and minus 1 rather than plus and minus 3. So what that indicates to me then is that the original graph has been stretched by a scale factor of 3 on parallel to the y-axis. So that's when we have y equals a fx. It would be a stretch scale factor a here. So if that is the case, a fx, what I'm going to have then for my first answer is, oops, so that's, what's that, 1 part a, isn't it? 1 part a, I'm going to be saying y is equal to, if it's stretched by a scale factor of 3, I'm going to say y equals 3 cos x would be my answer for part A. What does part B say? Part B then says, once we've got that, can we now do y equals f of x plus 4. So if y equals f of x plus 4, first of all, let's get rid of this sine graph. Let's just move it out of the way a minute, because I'm going to use my graph here that I've already got. So let's just get rid of all this bits here and say at the moment, remember, this is y equals cos x, not y equals 3 cos x. So if I want to make this 3 cos x here, then what I need to do is I just need to change those values to 3 and minus 3. Yeah, now I've got my y equals 3 cos x, and they're saying if that's y equals fx, what does y equal f of x plus pi over 4 do? Well, this is f of x plus a this time, and what that does is it will transform, or it will translate the graph minus a units in that direction. So if we're going to do that, then in terms of our key points, what we're actually going to have is, what have we got here? This point, this point, this point, and this point, they all need to move pi over 4 in that direction. So you've got to work out what all of those ones are. For example, 3 pi over 2 minus pi over 4, that's going to become 5 pi over 4. And you've got to do that for all those values. I've already calculated all of those, but they're all going to move across. So let's get rid of those. Let's actually shift our graph over. Now, I appreciate the fact that you're going to have to actually redraw your graph out to do that, but this video would take too long if I tried to do that, especially as now what I do need to do is to get rid of those old values there then and say, okay, what are the new values going to be when I'm doing those? I don't need any of those ones. So these new values here, and again, I will use red, obviously. You stick with one colour when you're doing it on an exam paper. But this is going to be, that's 5 pi over 4. That's pi over 4. This one here is minus 3 pi over 4. And this one here is minus 7 pi over 4. Whether you actually need the pi, 2 pi, minus pi and pi, that's up to you to do. I think that's clear enough for the examiner to see exactly what I've done here. And also it's indicating, if you hadn't already realised, that we've got an issue there as well. We've got a new point here that has now emerged, which is where it's going to hit the y-axis. So if I want to work out what that is, if y is equal to f of x plus 4, it's now 3 cos x plus pi over 4. That's the graph that I've got drawn here. And I want to see when the y-axis, well, that's when x equals 0. So at x equals 0, this is going to be 3 cos 0 plus pi over 4, so 3 cos pi over 4 here. and you can stick that in the calculator, you can do whatever. I know that cos pi over 4, for example, is root 2 over 2. I know that, but you can do it on the calculator. So that's going to work out to be that value there. And again, if I just change my colour to make that very, very clear to the examiner, 3 root 2 over 2. Yeah, I'm pretty happy that I would get all the marks for that in terms of the way I've displayed that as well. Let's have a look at the second part now then. So the second part is now talking about this graph here, which is a sine graph. I can see it's a sine graph because of that shape there, okay? And it's going between 1 and -1, so there's no problem here. But of course, you know, there's going to be a transformation. I would have expected the period of the graph to be 2 pi there, and it's only pi. So what's happened, let's go and have a look at sine. I did have it just a minute ago. There's sine. Okay, this is what sine, I'm going to get rid of this in a second, but this is just to explain it to you. This is what sine x looks like, and what they've got on their one is that basically, let's see if I can draw this on here, this whole shape there has happened, but it hasn't happened in 0 to pi, it's happened in between 0 and 2 pi, it's happened in 0 to pi. So what's actually happened is we've got that's gone on. It has been squashed with a scale factor of 2. Well, if it's been squashed with a scale factor of 2, that's y equals not a fx, that would be that stretch business that we just talked about before. No, I haven't got that this time. What I've actually got is y equals f of ax, like that. So if that's my situation, then let's get rid of all of that. Instead of having sine x, that was for the first part. For the second part here, I'm now going to say to part A, y is equal to sine 2x now. So y is equal to sine 2x. And then they've said once we've got that, then what happens if I do g of x minus 2? Okay, so if y is equal to g of x minus 2 this time, then this whole graph is now going to move down by 2 units. Okay, so that point there that was at 0 is going to jump down 2 points. That's going to be -2 here. This 1, when you jump that down, will be at -1, and this -1, when you jump that down, is going to be at -3. See if I can explain that a little bit better. Again, done a little bit of pre-work here. Where is it? Yeah, I drew this one in already just to save me time. Video's long enough as it is, but try and save ourselves a little bit of time here then. So this is the graph of gx, and what I'm now going to do is move the whole thing down by 2 units. So if I moved it down by 1 unit, it would look like that. Moving it down by a second unit, it's going to look like that. So what that means now is that when I'm doing that, what I've got to make sure I'm doing when I'm doing that is, if I extend that down a little bit just so we can see these. This is the important point, because this is the important point that they want there. That value there is -2, and also that minimum value there would be -3. But on the question says, sketch it out and show clearly the coordinates of the y-intercept. Okay, so the y-intercept 0, -2 here. I think that's clear enough to be able to get my marks for that one. This is y equals gx -2, or y equals, I don't need to put all this stuff in, I'm just showing off really at this point here. That's good enough, I think, for me to get the marks for that one, and then move on to the next question. So yeah, lots of stuff there involving the original graphs, the transformations, and then the way that you're going to be able to sketch these neatly and accurately. Hopefully that all makes sense to you all.